Have you ever seen so many knobs? Well, as I said before, in learning how to use mixers, we can disregard a lot of this and we can concentrate down just on one channel. In fact, I'm talking to you through this lavalier microphone here, which is plugged into channel 1 here. Let's go down the channel 1 strip and see what some of the knobs do. My microphone is plugged into the input of channel 1 here, and sure enough, I can adjust the volume of my voice with the fader. Check, 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 check. If I bring this channel fader up to the 0 dB mark, I'm going to get the best signal to noise ratio out of that channel fader, and any major adjustments to compensate for the differing outputs of mics or line equipment fall at the feet of the trim or the gain pot. Between the two of these, you can adjust the level that will go out to, say, your speakers or to a tape deck. Now here's mixing rule number 1. On many mixers, you could have up to a half a dozen different places along the mixer to adjust the level. And if you're used to just having one volume knob, this can be a confusing situation. I have volume or gain controls here at my trim pot, at my channel fader, at the left and right master output, and maybe even on my tape deck or amp inputs. And depending on what level I set between all of these volume controls, I can have everything from a crystal clear recording to a distorted, hissy mess. Now here's the thing, at each of these gain stages we have the ability to amplify the signal or attenuate it. Now our job is to make sure that the signal gets up to a nice healthy level very early on in the signal path, and then basically goes through the mixer relatively unchanged. Because here's the thing, amplification of signal brings in a certain amount of noise and distortion. So we want to keep that to a minimum. So what we want to do is at the trim stage, get it up to a nice level, and then through the mixer at the various other gain stages, it should be neither amplified or attenuated. This signal level is marked on many mixers as 0 dB. So in this case, I would take my left-right master, set that to the 0 dB mark, along with my channel fader here, and make any adjustments to my incoming signal right at the trim pot. For most mixers, this is normally the first gain stage that a signal sees upon entering a mixer. So if we get it up to a nice healthy level there, it should sail through the mixer nice and quiet. Now that we have a nice level on our channel number 1 here, the next thing we can look at is EQ. Now if you've ever used bass and treble controls on your home stereo, then you've already used EQ. You see, sound is nothing more than vibrations of sound waves through the air. The slower those vibrations are, the lower or bassier the tone is. The faster those vibrations are, the more trebly or higher the tone is. Sound vibrations are expressed or measured in cycles per second, or hertz. 1,000 cycles per second is said to be a kilohertz, and the following chart reveals what fundamental frequencies are generated by a number of instruments. Now it's important to realize that these instruments actually generate a range of frequencies, but for the purposes of learning about EQ, we can say that their fundamental frequencies are centered around these points here. So what this means for us is that if we had some sort of ability to amplify just a certain band of frequencies or a certain range of frequencies, we could effectively represent one instrument over another. Now, if you've never heard this, you obviously haven't been down Sunset Boulevard on a Saturday night. Just hear what happens when 200 hertz and below is cranked up on every car that goes right by. I think you know what I'm talking about. Anyway, a fader boosts or cuts a signal across all frequencies, where EQ boosts or cuts just a range of frequencies. We have 4 knobs of EQ on this mixer that allow us to boost or cut certain frequency ranges. Say, for example, this knob here allows us to boost or cut frequencies around 80 cycles per second or 80 hertz. You can hear how that's affecting my voice, adding bass and taking bass away. Similarly, we can cut or boost the higher frequencies at 12,000 hertz or 12K if you want to sound really hip. Hear how that affects my voice. Got more treble. We can take that treble away. Now you can see that both the low and the high frequency have fixed frequency ranges that they work on. In this example, 80 hertz and 12 kilohertz. Now the middle two knobs affect the mid-range frequencies, and they work in conjunction with each other to decide what frequency I want to center my tweak around, and then the amount of cut or boost. Let's boost the mids here, and by sweeping the center frequency around, you can see what type of mid-range that I can accentuate or cut. This type of EQ is called parametric, or more specifically semi-parametric EQ. We have those two knobs. One decides where that EQ point will be, and the second one decides how much you're going to cut or boost that particular EQ point. Now, a lot of other mixers, including this one, will have a center detent position. You'll find if you grab the EQ knob and get it to around 12 o'clock, you'll feel a slight click to it. What this is telling us is that this is the point where you're neither cutting or boosting that particular EQ point. And in fact, some mixers will even go a little further in that they'll have an EQ defeat button, which will take the EQ stage right out of the gain stages. Getting back to what we were saying before, we always try to get signals through the mixer with the least amount of amplification as possible. And EQ is just another amplification stage. So if we can try to use EQ sparingly, sometimes get a better sound right at the mic position, then start going hog wild with the EQ, we can always get a better signal.